Let's talk about the latest developments in AI research. I'm sure they'll spark an interesting discussion. First off, we have a paper from 2023, Brainformers, Trading Simplicity for Efficiency. This one is from Google DeepMind, and it looks like they're challenging the traditional transformer architecture. Can you break that down for us?
Certainly. Brainformer is a new AI architecture that builds on the transformer model, but allows for more flexibility in the arrangement of layers. The main idea is to allow different permutations of layers within the model, as opposed to the uniform structure typically seen in transformers. The model also incorporates sparsely gated mixture of experts, MOE layers, which enable more efficient use of compute.
Mixture of experts layers have been around for a few years now. Are the Brainformer MOE layers different?
Yes, they are a little different. Besides changing the topology of the network, Brainformer also introduces a new routing algorithm in MOE layers called expert choice routing, which enables perfect load balancing across the experts. That's important for scaling the model efficiently, and this is coupled with a neural architecture search to discover a good set of layer permutations.
This sounds promising for the future of efficient AI models. Were they able to measure any efficiency gains with this new approach?
They were. The Brainformer model showed faster training times and convergence rates compared to the baseline GLAM model. This is a relevant finding, which provides a path to building more efficient models without compromising quality, and the paper also reported improved performance across downstream benchmarks.
Next up, let's discuss Gemini, a family of highly capable multimodal models published in late 2023. Gemini seems to be a big step forward for multimodal models, especially with their focus on reasoning. What can you tell us about this model family?
The Gemini paper is quite interesting because it suggests that we can jointly train a single model on text, image, audio, and video, and have it work well across all of these modalities, even when compared against models which are narrowly tailored to single modalities. That's exciting because it could enable all kinds of new applications which require reasoning over several modalities at once.
Gemini is a family of models, is that right? Do they all have the same architecture?
Yes, that's right. There is a Gemini Ultra, Pro, and Nano. These models share the same core architecture but differ in size, similar to Palm 2, to serve different needs. Gemini Ultra is a larger model focused on state-of-the-art performance. Gemini Pro is a smaller, more efficient model, and Gemini Nano is a series of very small models designed for on-device deployments.
A multimodal model that can run on device. That could be a game changer for certain applications. How did the different models perform on their respective benchmarks?
All models showed impressive results and improved upon their predecessors. For instance, Gemini Ultra is the first model to achieve human expert performance on MMLU. It also shows remarkable performance on multimodal tasks, like the recent MMMU benchmark. This is especially impressive since MMMU is designed to test college-level knowledge and reasoning. These results suggest that we can build a single model that can do many things well across modalities without having to rely on several specialized models.
Moving on, we have AI and the opportunity for shared prosperity from January 2024. This one seems a little different from the other two, less technical and more focused on the economic and societal impacts of AI. Would you agree with that?
Yes, indeed. It's a thoughtful exploration of AI's potential to drive economic growth, improve productivity, and help address urgent challenges, particularly in the global south. It takes a look at prior general purpose technologies and the impact they had on the economy, and suggests AI has similar potential, but also has unique features which depart from prior technologies like electricity, the steam engine, or personal computers.
The paper mentions the possibility that AI could lead to adverse outcomes such as job losses and income inequality. These are genuine concerns about AI's impact on jobs. How does the paper propose to address these challenges?
The paper dives into historical examples like the introduction of ATMs, which initially sparked concerns about job displacement for bank tellers. But in the subsequent 4 decades, it actually led to an increase in both the aggregate number of bank branches and demand for bank tellers because it reduced costs and made it possible to open more branches, thus increasing the overall demand for labor. The paper suggests that because of its ability to automate tasks, AI can have a similar positive impact on jobs and productivity, but acknowledges that we would need to tackle some key challenges and that a policy agenda that prioritizes labor complementarity would be needed.
It's reassuring to see that AI has the potential to create new opportunities, even in the face of job displacement, but we need to get it right. Now, our final paper is Scaling Instruction Fine-Tuned Language Models, published in early 2024, which introduces FLAN. FLAN seems to be a powerful technique to improve performance across a broad range of models. What is FLAN, and how does it achieve these improvements?
FLAN, or fine-tuning language models, refers to a process in which a pre-trained language model, like PaLM or T5, is further trained on a large collection of diverse tasks expressed as instructions. This technique is particularly impactful at smaller scales and can improve a model's zero-shot and few-shot capabilities, reducing the need for prompt engineering, which can be difficult for non-experts.
The paper discusses the importance of scaling the number of tasks. It seems like the models benefited from being fine-tuned on a huge number of tasks, which can lead to better generalization capabilities. It also looked at the impact of fine-tuning models on chain of thought data and found this to be important for reasoning capabilities. Can you expand on that?
Yes, that is correct. Similar to other scaling laws observed in large language models, increasing the number of tasks led to improved performance. The paper also shows that including some chain of thought data during the flan stage helps models maintain the ability to reason step by step. That's a significant finding, as it shows that we can effectively train a single model to be both a factual language model and a reasoning engine. The paper also shows that this unlocks zero-shot caught, which enables the model to generate a chain of thought without the need for exemplars, which can be difficult to compose correctly. In summary, the papers show that AI continues to advance at a rapid pace and in sometimes unanticipated ways, with significant implications for both our economy and society. While there are genuine concerns to address, especially regarding the impact on jobs and the need for complete digital infrastructure, AI has a tremendous potential to benefit us all.
Thank you for discussing this.